All right, buddy, welcome to week 6. This week we're going to finish up module 3, talk a little bit more about lists and a bunch of other stuff. I've gone over how to present this information and in what order maybe it should be presented in, but I hadn't really come up with anything. So I'm just going to go through a bunch of stuff. I hope it makes sense in the order I go through it, and we'll see where it goes. This week there are 3 labs that I need screenshots for. And this assignment, student grades, is going to be something you do in PyCharm or whatever IDE you're using and submit the Py file. For this particular assignment, student grades, I have given you a variable here. This is a multi-dimensional list, and you won't get the right answers unless you use this variable. Probably doesn't make sense right now, but we're going to get into the lesson here in just a second. So, we're talking about lists. What is a list? A list is declared like this. This is an empty list with square brackets. You can populate it now, or you can have user populate it or whatever. It can be, lists in Python are pretty unique because you can have numbers, you can have strings, a bunch of other stuff in here too, but it doesn't matter. In many other languages, you can't do this. So we have a list there. You can see that it has 4 things in it. How do we access just one of those if we want one of those? We have to use what's called the index. So, and I think I've probably said this a few times, but the computers start counting at 0, where we start counting at 1. So you have to remember that for these indexes. So for instance, if I want to print the word strings out of this list, I need to get the correct index. So if you can see, this is going to be 1, 2, 3, and 4, or 0, 1, 2, 3. They start counting at 0, 0, 1, 2, 3. So if I tell the computer to grab index 1, it's going to grab the second object. And if I run this, it prints strings. So this is the index, and this is how you get an object out of here. How do you print more than one? Let's see, if I just print list, let's see what it does. It prints everything. You get the brackets, you get the punctuation and the commas and everything. So it prints the whole list. If you want to print it neatly, you have to use a for loop. We went over that last week, right? And I think I may have touched on like in, we think we did range. So just, we can do like this, for item in list. Print item. So it's going to go through the list and look at each thing. And for every item in that list, it's going to print that thing. Now this item here, I think we talked about this last week as well. It can be anything. You can say you can say anything. For anything in a list, print. Well, you got to make sure you're printing. That becomes a variable. And then you're printing that variable. And it'll print it on each line, just like that. So if I want to add something to the list, where's my notes? Here we go. I want to add something to the list. We use the append method. List.append. And in here you append whatever you want to add. We'll add another string. And then we print the list again. You see here it's added another string right onto the end of the list. That's what append does. Append will add it to the very end of the list. What if we want to put it into the middle of the string? Let's say I want it to come right after strings. Then we'll use the insert method. And you have to specify, this takes 2 arguments. You have to specify the index that you want to insert it at. So if I want it to come right after strings, it's going to be 0, 1, 2, right? We'll put it in the second thing. And that's how you do it. You give it the index and you give it what you want to put into the string. If I run that, one strings, another strings, prefix. So put it right where I want it to go. And then if I want to delete, we can just delete that. Is going to be 0, 1, 2, yeah. I'm not sure if I'm doing that right. Yeah, okay. So that's not a method. It's a function. Yeah. Well, so I didn't do the append anymore. This is not what the string looks like anymore. So if I delete list 2 with the index of 2, 0, 1, 2 is going to delete that 3. It got rid of the 3. So you've got insert that's written like this, and append. Let's do all 3 of them right here so you can see. Let's see. We did 2. That's the arguments for insert. So append just goes on to the end. So we're going to do an append. It'll put append on the end. And then we're going to do an insert, which will put another string in the second place right after strings. And then we're going to print the list so you can see that it worked. And then we're going to delete list object 2, which will be this another string, and then print the list again. All right, I'll run that. See, it inserted or appended another string on the end. Then it inserted another string at the 2 index, which is the third space in the list. We printed that list so you could see it here. And then we deleted list item 2, which is just another string, and printed list again. The append is still here, and the delete is gone. So that's append, insert, and delete. Pretty simple. All right, cutting to multi-dimensional lists. It's declared the same way a list is declared, but instead you have lists within lists. Think of it as like a spreadsheet. You've got rows and columns. And the columns will be the lists, and then the rows will be what's in that list. So like the columns are all one list, and then there are other lists running down. So in the top row, like column A, you're going to have 1, 6, and 11 going across, and then on the second row it'll be 2, 7, and 12, like that. So if you want to grab this 13 out of the list and print it, you would print, you have to get the index for the list that's in, the first one. And remember, it's 0, 1, 2. So multi-list 2. And, well, let's just print that real quick and see what happens. It'll print the whole last list. If you want to grab just that one out of the list, you need to give it the index. Remember, 0, 1, 2. So they all start at 0. All the lists start at 0, and then each one of these will start at 0. So like the 8 and the 3 are also 2s, but they're going to have a different first number because they're in different lists. So if you print multi-list 2, 2, you get just that single index. Now let's say, what if you want to do something to each one of those? You have to use a counter and kind of iterate through the list so that you can access each variable and then to do something to it. Let's use the list first. So you do that with an I loop, and I think we covered this last week, but I can't remember. For iron range len list. So for every item in the list, well, it's not looking at the list. It's looking at the number right here, right? So we're performing a range, we're giving it a range within the length of the list. So if this list is 5 items long, this number is going to be 5. So it's going to run through this loop 5 times. If the list is 100 things long, it'll go through 100 times. You could just put the number 5 here, or a range of 5, but this way it doesn't matter what length the list is. So for iron range list, let's print that particular variable. And you can see it goes through, and it goes for each one, 5, 10, 15, 20, 25, and it grabs each one. So the first time it goes through this loop, this I represents 0. So it grabs the 0 index and prints list 0. Then it goes through it again and prints list 1, and then list 2, list 3, 4, and so on until it goes through and finishes. Let's say we want to add all the numbers together. I'm not sure if you have to declare this outside or not. Let's see if this works. No, it has to declare it outside. Okay. So you declare a variable to hold the number, and then each time it goes through, it's going to add that number to the total. So it'll add 10 to 5, 15 to that total, 20 to that total, until you get a total number. And then when you're done, it should change that total variable and print it at the bottom. So let's see. So the total is here, 75. Is that right? I don't know, and I'm not doing the math, but I think so. So this way it'll iterate through. That's one list. And so if it's a list of names and you want to print all that, I guess you can't add all the names together. But if they're student grades, hint, hint, this is a good way to add them all together. What if it is, you want to work on this multi-dimensional list, right? So for I in range len, let's do the multi-list. Let's just get rid of all this. All right, and then for j in range multi list. It's giving me an error. I don't know why. Now let's just see if this works. Oh, I didn't do the length multi-list. That's why. M-U-L-T-I. No, I spelled it wrong. M-U-L-T-I-L-I-S-T. Is that right? Nope. Still spelled it wrong. Goodness gracious. Okay, no more red. This should work. So what we're doing here is for each item within the range of the multi-list. So it's going to look at 0, 1, 2. That's the range, 1 to 3, or 0, 1, 2. That's the length of multi-list, and that's the range we're looking at. For those 3 lists, we're going to do another for loop for each item in the sublist. I hope that makes sense, because this is kind of important. So if I run this, it should print each one of these as it goes. Yep, there it goes. It does it so fast you can't really tell that it's jumping from list to list. The output just looks like it counted the whole way through. But this is how you want to do it. And so if I wanted to total that, let's not print that. Let's just print. So if we're going to add all these together, I don't know what that total is, so I can't check it. But let's see. Oh, I didn't tell it to print the total. I'm going to assume if you add up all these numbers, you get 120. Does that make sense? If you just want to add, I'm going to leave it like that. I think you're smart enough to figure out the rest of it. So that is lists and multi-dimensional lists. There's some talk about and ors. Now we went over if statements last week. So if n is equal to 10, we want to do something. Well, let's just make this a working function. All right, so goodness gracious, forgetting everything today. All right, so if n is equal to 10, we're going to do something. If we run this, it's going to ask me for a number. I put it 10, it's going to print do something because that's what we do. But if we want to, let's say if n is greater than 10 and, or is it like this? Oh, man. Ah, it's just lowercase. Forget. Sometimes it's all capitals. Sometimes I think it's Java or JavaScript where you do these things. I don't remember. Anyways, and in this in Python. And n is less than 20. We're going to tell it to do something. Else, we're not going to do anything, I guess. I'm winging this by the seat of my pants, folks. All right, so you got this and keyword in there, right? So if the number is greater than 10 and less than 20, it's going to do something. Otherwise, it's going to do nothing. So we run it, enter a number, say 15, it's going to do something. Run it again, and we enter 21, does nothing. Let's make sure it works on the other end. If we enter 5, does nothing. So you can use this and in these if statements and in several other places. If you have two conditions and you want both of them to be true, put the and in there. You can use or. If it's less than 10 or greater than or equal to 20, we're going to do something. Otherwise, we're not going to do anything. So let's see, greater than 10. If it's 11, it's going to do something. And likewise, if the number equals 20, which is kind of greater than 10 anyway, so still going to work. But if it is, I guess that's a bad example. Let's do 5. Because that is not, it won't meet the second condition. So again, put in 20, it does something. If I put in 6, I'm just going to do nothing. But if I put in 5, it does something because either of these statements can be true. Only one has to be true, not like the and where both have to be true. And we kind of did the not, you know, if with the exclamation point, but you can also use the not keyword. So if it's greater than 10 and not, let's say 15. I got a red mark there, so I'm not sure if that's right. Just remember that not is a keyword. You're almost never going to use it because you're going to use the cool little not equal to. So no big deal. It talks about bitwise operations. And let's go over that real quick. I got a cool little PowerPoint here. So, a bit is a unit of measurement or capacity for data. A bit is read by the computer as 1 or 0. That's where we get binary. It's only 1 or 0, and it reads the bits. I think you already know that. 4 bits equals a nibble. 8 bits is a byte. And then we get kilobytes, megabytes, gigabytes. It just keeps on going. Petabytes and zettabytes and terabytes and all that good stuff. Importantly, you need to know what a bit is. In your example in the book, it's going to give you these variables. So we've assigned the variable I, we've assigned it the number 15, and J, we've assigned it the number 22. These are integers, not strings, but it's the same thing. It's using 32 bytes of data, or 32 bits of data, to store that in the computer's memory. And how it does that is with ones and zeros, because again, we're back to binary. If you look at these, it's 32 bits. The first lots of them are zeros, so they don't really mean anything to us. But if you look at the last 8 bits, this is how you read binary code. You got to break these up into 8-bit sections. We're not going to pay attention to those first 3 because they're all going to equal 0. But this last set of bits, we're going to calculate or see why that equals 15 and 22 respectively. So if you break down the I, which is 15, this little chart is how you calculate how much it's worth, for lack of a better term. If there is a 1 in the 1 place, then you add the 1. So, well, here, I'll just keep going and show you. So all the zeros equal 0, just like the first 3 sections. We don't pay any attention to those because they're all 0. But that last section has a 1 in the 8, 4, 2, and 1 bit. And if you add all those together, it's 15. That's how it stores it in computer memory. Same with the 22. See here, it's got a bit in 16, 4, 2, and that equals 22. This is how it gets all the numbers and the ASCII stuff. Now you'll see this later as Python compares strings. You don't have to pay attention to it right now. Well, I'll go ahead and explain it right now because I explain it again later anyway. If we're looking at, we just looked at numbers here, right? So we assigned the value 22, but all the characters on the keyboard, letters, uppercase, lowercase, and all that also have, they're read as bits just like everything else. There's just a chart for that. In this comparison, they're comparing strings. We're looking at alpha, and alpha. Is alpha equal to alpha? And it is. It's not equal to alpha with the big A, which makes sense. They're not the same, so they're not equal. Oop, dang it, what did I just do? So, what gets me here is that beta is greater than beta, and this is a true statement. The big B I always assumed would be weighted more, but it's not. And this is why. This is the chart that's used to for all your keys on your keyboard. It's called ASCII, ASCII. I forget what it stands for, but you convert binary to hexadecimal and ASCII. And if you're looking at letters, the hexadecimal here value, what we're looking at, B, capital B and little b. The capital B value is 66 decimal, and little b is 98 decimal, which makes the little b bigger than the big B. You don't need to know that right now. We'll catch up on it later. But this is just kind of something that you'll need in your other computer classes right here. This little chart, 128, 64, 32. This is how you convert binary into hexadecimal, and from hexadecimal you can use the ASCII chart to figure out what character it is. So if you see a bunch of ones and zeros, you can use this method to actually read what it says. I hope that makes sense. I try to keep these videos short, but there's a lot of stuff to cover, and I want to make sure you understand it all. All right, so we did the methods: append, insert, delete. You know how to count through a list. Oh, lastly, well, let's stay on lists real quick. So we got a list. 1, 2, 3, 4, 5. Regular list. There's something I should have went to. If 6 in my in list. This is another way you can use the lists. So you could just use this in command and it'll look at the list, right? It'll look through everything in the list and see if whatever you put here is in it. So if I run this, it's not in the list. But if I run 3, it's in the list. So let's say you have a list of names. Bob. I don't know. I can't think of a name. Names. Bubba. All right, so if let's say Bubba's in the list, it prints it's in the list. But if you're looking for Robbie, it's not in the list. This is a good thing to remember too if you got a lot of data to go through. If it's in there, if it's in there. You can also do not in. Or is it not? Yeah, there you go. If Robbie's not in the list, we'll print that he's in the list just because I don't want to change it. But so Robbie's not in the list, so we print it in list. It's not in the list. I just want you to be aware those keywords are available, and you may find some good use for them later on. All right. Now, lastly, sorting a list. And it's just a pain in the butt. This is, I have trouble with this every time I do it. But let's just say 19, 13, 6, 2, 18. We have a list completely out of order, and we need to sort it and make it, go from smallest to biggest. They tell you about the bubble sort in the book. I don't understand their description of it, but they do make reference to bubbles rising to the top. So I don't know if the little numbers are rising to the top or the big numbers are rising to the top. What's the top, the left or right? I don't understand their description of it. It doesn't make sense to me. We want to put this in order. In order to do that, we're going to compare. We're going to look at the index and the index right after it. We're going to look at those two at the same time. If the index after the index is bigger, we're going to swap the two. So we'll do a little for statement for our thing. I always use I, but a lot of people get confused about, what is I? What does that mean? It's just the thing. For the thing in the list. For thing in range length list. Right? Or thing in range, the length of the list. So for as long as the list is, we're going to keep on doing something. We're looking at the thing. And although this isn't a multi-dimensional list, we're going to do another one. For thing 2, we'll just use J. So we're going to go backwards, sort of. We're looking at the thing, the index, and then the index minus 1. Right? So we're going to look at two things at the same time. We're going to look at the index, and it's going to skip the first one and go to the second one. So it's going to skip 0, go to 1, and then it's going to look at 1 and the length of the list minus 1 is the end, and it's going to swap the 2 if one is bigger than the other. So if list J is greater than list J plus 1, confusing, I know. Again, we're looking at two indexes, and if the one that's greater, if we're looking at index 0 and 1, if 1 is greater than 0, it's going to swap the 2. Does that make sense? We're going to do some. We're going to swap the 2 right here. Now what we're doing here is declaring, or we're assigning values to two variables at the same time. It just makes more sense to me to do it this way, but I will write it another way, so hopefully you'll understand better. So this line right here is the same as writing two lines of code where we would go list J is now going to be the value. We're going to assign the value of list J to from the value list J plus 1. So whatever J plus 1 is going to be assigned, the value is going to be assigned to list J. Just like that. And then we're swapping them. So J is going to equal J plus 1, and J plus 1 is going to equal J. Swapping the two. These two lines is the same as this line right here. I just like doing it in one line. Makes it a little easier to understand, maybe. But it's the same code here. So if we do that, and then we print the list, you should see, if I did it right, list is now in order. Ah! What is that? For generator on top of the list. Wait a minute. Parentheses. So I wouldn't understand what that was. Make sure your len length is minus 1. Then make sure your parentheses are in the right spots. So now we got 2, 6, 8, 13, 18, 19. It is all in order. The bubbles rose to the top, whatever that means. I never understood the concept of bubble sort. Maybe you will. Good for you. That's awesome. This is the simplest way to do it. There are other more confusing ways, but it is in the book, and I think it is a lab. I'm not sure. Know how to sort a list. Bubble sort. And you'll see that again in all languages. You'll do a bubble sort. I think that is it for this week. You'll do some other stuff in the labs, and then you have your assignment. For the student grades assignment, you're going to find the average for each one of the lists within the lists. I think I gave you enough to do that with. Finding an average is easy. Total them all up and divide by the number. So if I wanted to find the average of this list right here, range length so Oh my goodness. Let's see if this even works. 11. Use my little calculator here, make sure that's right. So I got 19 plus 13 plus 6 plus 2 plus 18 plus 8 equals 66. And if you divide that by 1, 2, 3, 4, 5, 6, you get 11. So that is how you get an average. The math is super simple. Just make sure you're going to be doing a multi-dimensional list and getting the averages for all 5 of the students in there. If you have any questions, let me know, send me an email, I'll help you out. All right, thank you.